All right, it is 12:12, and I think we got everyone in here from the waiting room. So code today is LRPEHB. For the bell work, find the sine, cosine, tangent, cosecant, secant, and cotangent of pi over 2. Got 30 minutes. Yes. Oh, yes. All right, so let's go over this. You should have hopefully found, using the unit circle, that's your angle, pi over 2. Is right here. And the coordinates of that point are 0, 1. So if you use your formulas then, the sine of pi over 2 is just the y value, 1. The cosecant of pi over 2 would be the reciprocal of that, 1. The cosine of pi over 2 is just the x value, 0. The secant is the reciprocal of that, 0 divided by 1, which is undefined because you can't divide by 0, or 0 divided by 1. Who wrote that? I want to know the name of the person who wrote that. 1 divided by 0, which is undefined because you can't divide by 0. Tangent of pi over 2 is your y over x value, or 1 over 0, which again, can't divide by 0, so that's undefined. And the cotangent is pi over 2 is the reciprocal of that, 0 over 1, which is just 0. So those are our 6 answers. Questions, or does anyone need more time to write? All right, and today, what we're going to do is 4.3 is actually broken up into 2 parts. There's a part 1 homework that's due tomorrow. There's a part 2 homework that's due on Monday next week. For the part 1, we're going to do these first 2. Use our geometric definitions of our trig functions to evaluate and solve problems. So actually today's going to be a pretty easy day. And we actually will probably even get done early today. All right, so this should already be in your notes. If not, you could take a picture of it. But I don't want to linger on this slide too long because, again, this was in your notes for 4.1, I think. For any right triangle, give it an angle inside that triangle. You can label the sides opposite, adjacent, and the hypotenuse. The side is the opposite over hypotenuse, sa, ka, toa. And the reciprocal functions are just the flipped fractions for each of those. So cosecant is the reciprocal side, so it's hypotenuse over opposite instead. So we're going to mainly use these to solve the next few problems we have. So for example, first one that I would like you to try to solve is this one. Given this angle here, can you tell me what the sine of that angle is, the cosine, the tangent, cosecant, secant, and cotangent? And for this one, I will I'll do one of these for you just to show you what I'm looking for in an answer. I'll go ahead and do tangent. The tangent of your angle is supposed to be the opposite side, which in this case would be 4, over the adjacent leg, which is 3. So the tangent would be 4 over 3. Tell me what the fractions are for the other 5 trig functions. I'll give you 3 minutes. All right, so for sine, first you have to find the hypotenuse because the sine is the opposite over the hypotenuse. Can anyone tell me how do I find the hypotenuse for this right triangle?
A squared plus B squared.
Yeah, I think you're both saying Pythagorean theorem, a squared plus b squared equals c squared. You're both right. That's exactly what we want to do. 3 squared plus 4 squared will give us the hypotenuse squared. So 9 plus 16 is c squared. So c squared is 25, which means c is 5. So then sine is opposite over hypotenuse, so it would be 4/5. Cosecant then would be the reciprocal of that, 5/4. Cosine is adjacent over hypotenuse, so it's 3/5. Secant is the reciprocal of that, so it's 5/3. And the reciprocal of 4/3 is 3/4. Yay. Any questions about this one? Okay, so that's the first type of problems that they're going to ask you about on the homework. You could take a picture of this slide if you would like. I might give you a minute to at least write down this column. The rest of this stuff are your special angles, but that you can use to solve problems when you have angles of your triangle that are 35, 45, or 60. But to be honest, these two right here those are just pulled straight from the unit circle, right? If you look at the unit circle at pi/6, the y value is 1/2, the x value is square root of 3/2. So if you want to take a picture of this whole thing, that's fine. But really, this part is already in your notes because it's on the unit circle. This part might actually be useful because although you can get it from the unit circle by doing y divided by x, you still have some simplification work that you'll need to do. And so these are the simplified answers of y divided by x, y divided by x. And as a result, they might be more useful to you in this form. So I'll give you a minute to copy those down if you'd like to. All right, does anybody need more time to write? Okay. Then, here's another thing where you just might take a picture or you might sketch down these really quick. So when you're doing application problems for trigonometry, a lot of them will deal with angles of elevation or depression. So just to be clear, what an angle of elevation means is if you're the horizontal is our initial side of our angle. Then the terminal side of that angle is the line connecting the observer to the object in the air. Similarly, angle of depression would be that angle when you are going clockwise in the negative direction instead. Okay, I'll give you a little bit of time to write that down if you'd like to. All right, does anyone need more time to write? Okay. So I think the next thing we're going to do then is some practice problems. So let's say that you go out walking and you find a really good looking tree. So you, like any normal person does, goes up and hugs the tree, and then you wonder to yourself, I wonder how tall this tree is. So you pull out your ruler or tape measure, which you keep on you at all times, and you measure a distance of 50 feet from the tree. You then take out your clinometer, which is just a protractor instrument you made by taping a straw to a protractor and attaching a string to that protractor with some weight, so that when you look at the treetop, the angle through the straw will let you see the change in the angle, and then you can find out what that angle of elevation is using your clinometer, like everyone does. And then you record that the angle of elevation is 71.5 degrees. How do we find out how tall the tree is? Well, this actually isn't too bad, because what we have constructed here is a right triangle, where this is the opposite side and this is the adjacent. So if we are given that the adjacent side is 50 feet and our angle is 71.5 degrees, how do we find the opposite side? What trig function relates the opposite to the adjacent? What trig function has the opposite and the adjacent in it? We have a tangent. I was going to say, you have a 2 in 6 shot, because there's actually 2. You could do tangent, which is what I would do, is opposite over adjacent. You could have also used cotangent, but I will tell you to generally you don't want to use the reciprocal functions because your calculator doesn't have reciprocal buttons on it. We could still do that, and I'll show you later how to do that. But okay, so if we plug this, or the tangent of opposite is, why I put question mark, is y. And we're asked to find what's y. Okay, so if I plug these in, we get the tangent of 71.5 degrees is equal to 50, or sorry, y over 50. And I want to solve this for y. So to get y by itself here, instead of dividing by 50, I'll multiply both sides by 50. And you should get then that y is equal to 50 times the tangent of 71.5 degrees, which, if you type into your calculator, is about 149.434 feet. Okay. If you did not actually type that in, you should try typing that in right now to make sure that you, one, know how to type it in, and two, that your calculator is giving you the right answer. So I'm going to give you a minute. Type it in, actually do it, make sure your calculator is giving you the right answer. All right. Did anybody not get 149.434? About. Sweet. Okay. Let's do one more and then a guided practice, and that's the end of class. So after you now know how tall the tree is, you then look over at this river and say, hey, I'd like to do some more math. So you set out and walk perpendicular to the river for 200 yards. You then choose an arbitrary angle and walk back to the river for 400 yards. Again, using your tape measurer to measure that the whole time. We want to find what is that arbitrary angle that was created by your walk. Well, to do that, again, we'll label our triangles. This is the opposite side, and this is the hypotenuse. So we know the opposite side is 200 yards. The hypotenuse is 400. And we are asked to find what the angle is. So what trig function relates opposite and hypotenuse?
Sine.
That's right, sine. You could have also used cosecant, but again, I wouldn't use those except in certain situations, which we'll show about later. All right, so the side of our angle would then be the opposite, 200, over the hypotenuse, 400, which is the same as a half. And now there's actually two ways that you could get this angle. A half is a special ratio. That is a y value on our unit circle. So we can find what theta is just by using this unit circle. If you look at the angle pi over 6 are 30 degrees, the y value at that point is a half. So you know just from the unit circle that this angle is 30 degrees, or pi over 6 radians. Again, but there's another, you could pull that from that special angles chart that I gave you, or the unit circle. But the other way you could get this is, if I want to get the angle by itself and get rid of the sine here, then all I have to do is take the inverse sine. So my angle will equal the inverse sine of a half. And if you type that into your calculator, you get 30 degrees. All right. Does everyone know how to type that into your calculator? Is there anyone? Let me just show you. All right. So I'll give you a second to write this down, and then I'll just show you what that looks like in the calculator. Okay. So clear this. Stop share whole screen. If you pull up your calculator, to do that, first make sure hit mode. Make sure that degree is highlighted for your mode. And then to do that, you hit second side. And then 1 divided by 2. And you'll get 30 degrees. All right. So then last thing we're going to do today is problems for you to try. So for this triangle, find the value of A and C for this skateboard ramp we're trying to find. C is the length of the actual ramp, and A is how long the ramp is horizontally. With an angle of 18.4 degrees, this side of your right triangle is 4. I'll give you 3 minutes. Then we'll go over it. Okay, so the first thing you should do for this problem is label your triangle. So this is the opposite. This is the adjacent. Oh, actually, hold on. Before I get started, I do want to share my whole screen for this one. That way you could see, I'll show you how to do the calculator stuff for secant, cosecant, and all that stuff. All right, so opposite, adjacent, and hypotenuse. If you want to find the hypotenuse, given the opposite side, we asked the same question we asked earlier. What trig function relates opposite and hypotenuse? And I'm going to go ahead and use cosecant this time. The cosecant of your angle is the hypotenuse over the opposite. So for our problem then, we would have the cosecant of 18.4 degrees is equal to C over 4. So to solve this for C then, instead of dividing by 4, I would want to multiply both sides by 4 to get C is equal to 4 times the cosecant of 18.4 degrees. Now to type that into your calculator, you will run into an issue because your calculator does not have a cosecant button. It's just a sine, cosine, and tangent. So to do that, the easiest way is just to take 4 times, well, what is cosecant? It's just 1 over sine of 18.4. And there you go. You get the answer, 12.672. Which, by the way, is actually the same work that you end up doing if this was sine. If this was sine of 18.4, you would have 4 over C. So you'd multiply by C, and then you would divide by sine, and you'd still end up with 4 times 1, which is 4, divided by sine. To find A then, let me show you how you would do that way if we didn't use the reciprocal. So to find A, given the adjacent, you would say which trig function relates opposite and adjacent, and that's tangent. So you would get the tangent of 18.4 is equal to the opposite side 4 over the adjacent side A. And again, to solve this for A, I would multiply by A to both sides to get A times the tangent of 18.4 equals 4. Now A isn't in the bottom of a fraction anymore, which is great. But I still need to get it by itself. So instead of multiplying it by tangent of 18.4, I would divide both sides by the tangent of 18.4. And then you would get, type that into your calculator, 4 divided by the tangent of 18.4 is 12.024. All right. Questions about either of these two problems? None? We're all good? Okay. All right, you got the rest of the hour then, which is what, 18 minutes? Do you know the schedule that this class runs for 56 minutes, really? They say it runs for 51, but from 12:12 to 1:08 is 56 minutes. Like they made this class a little longer on Wednesdays than it's supposed to be. Anywho, I guess it gives you more time to work on the homework. So for the rest of the hour, then you can work on the homework. There's only one part that you have to do today. That's due tomorrow at midnight. I think it's like 6 questions, maybe 7. And if this lecture made sense to you, I think those will go by pretty quick. If you need help while you're working, I'll be here till 1:08. So just let me know in chat and I'll help you out. Otherwise, use your time wisely, everybody. I should also say, if you